right, here's our next example. So now, I've already got our goal form written out. So let's just dive in. Now this is kind of nice. We already have the 1 where we want it in the first column. So let's go ahead and get our zeros. So let's turn this 2 into a 0. The way that we'll do that is by -2 times row 1, because that's where our 1 is, plus row 2, that's where the number we're trying to turn into a 0 is, and we store that in row 2. And I do want to emphasize these last two should always be the same. This is what our allowable Gauss-Jordan, our allowable steps, or one of them, is. The one thing that you absolutely cannot do is something involving row 1 plus in row 2 and storing that in row 3. That would mean that none of the information from row 3 is worked into the new row, and you've just sort of wiped it out. So that would be bad. This is what we always want. So our constant times a row plus another row, and that result stored in that second row. Okay. Anyway, this is the 4th example. We've done this a bunch by now. So I'm recopying row 1. And so -2 times 1 plus 2 is 0. -2 times 3 is -6 plus 6, well that's 0. -2 times 7 is -14 plus 14 is 0. Oh dear, -2 times 13 will be -26, and what will that be? -49. And now I'm going to recopy row 3. And we are actually going to stop here and think about what this second row means. This row represents an equation, because each row represents an equation. This represents the equation 0x plus 0y plus 0z equals -49. But of course this left-hand side here reduces to just plain 0. So that's really 0 equals -49. That is a contradiction. That's an equation that is always false. As soon as you get to a contradiction, notice that we have not gotten to our goal form yet. We really haven't even gotten very close. But as soon as you get to a contradiction, you can stop, because the only way you will ever get a contradiction is if the system has no solution. So this system has no solution. Now remember how we talked about whether or not, what the graphs of these systems looked like. Each equation is a plane, and the fact that adding the first 2 rows together gave us something where the left side was entirely 0 and the right side was a non-zero number means that this these first 2 equations that are represented by those first 2 rows are 2 parallel planes. Since 2 of the planes in my system are parallel, then there's never going to be an intersection point for this particular system, for every equation in this system. You don't have to say anything about that in your answer. It is enough to recognize the contradiction and state that it has no solution. Really, your answer is just no solution. All right. Well, that